Today I'd like to demonstrate the happy and sad balls. So these two rubber balls have different properties. They're made out of different stuff. The happy ball bounces when I drop it. The sad ball doesn't. So what I'm going to do is I'm going to roll these one at a time down the ramp, and we're going to observe the effect that the impact has on the board. So I'm going to start off with the sad ball, and I'm going to place it 30 centimeters from our board, and we can observe that it just stops at the board. The happy ball, in comparison, when rolled from 30 centimeters, bounces and knocks over the board. So why do you think that could be? Well, let's consider what we've learned about impulse and momentum. We learned impulse momentum theorem, which says that impulse equals a change in momentum. Impulse can be calculated as force times a change in time. Change in momentum, we would calculate mass times a change in velocity. We are going to assume that the two balls have the same mass and the time of the impact is the same for each trial. If I do that, and I say mass is the same, time is the same, then what we can see is that if the ball with the greatest change in velocity is going to produce the greatest force on that board. So let's think about change in velocity. For the sad ball, it initially had a velocity toward the board. And when it reached the board, it stopped. So if we say that initial velocity is positive, the final velocity is 0, the change in velocity being the final velocity minus the initial velocity would be 0. Let's say our initial, we'll throw a number in there, 5 meters per second. So 0 meters per second final velocity minus 5 meters per second initial velocity gives us a change in velocity of negative 5 meters per second. The happy ball had, let's say, an initial velocity also of 5 meters per second, and it bounced back with a final velocity, and I'm going to call down the ramp the positive direction, so that would make my final velocity negative 5 meters per second. So the change in velocity for the happy ball, final velocity minus initial, final velocity is negative 5 meters per second minus the initial velocity of 5 meters per second gives me negative 10 meters per second for my change in velocity. So because the happy ball bounced, it had a greater change in velocity, producing a greater force on the board, knocking it over.